Hello. Today we'll be solving a problem on projectile motion. The problem is that a football is being kicked at an initial velocity of 18.0 meters per second and at an angle of 31.0 degrees to the horizontal. And we have been asked how long would it take for this football to hit the ground again. So we're basically being asked how long does this football stay in the air, or like how long is the time of flight for this football, right? Um, Before we get into any kind of solving, I'd like to say that we are assuming that there is no effect of air resistance on the football, which is definitely not the case in real life. But for the sake of the solution, we are assuming that there is no air resistance, right? So first, I drew a simple diagram depicting the scenario of the problem. So we have an initial velocity vi equal to 18.0 meters per second, and the football is kicked at an angle of 31.0 degrees. There's a dot that shows the maximum height. This will be important as you'll see as I solve the problem, right? And I've assumed that the upward direction is positive and the downward direction is negative, right? Um, so first thing that I like to do is write down the known quantities. And we know two quantities for sure, that the initial velocity at which the football was kicked is 18.0 meters per second. And the angle at which the football was kicked is 31.0 degrees. Now, I also like to write down what is it that we're trying to find. So we're trying to find the time it would take for the ball to hit the ground again. This will be denoted by capital T in the solution. So first, I have written down the basic kinematic equation. V equals to U plus AT. Here, V is the final velocity of the object, U is the initial velocity of the object, A is the acceleration of the object, and T is the time period. Now, I have written this same equation in terms of vertical components of the velocity. Um, this is because we are trying to find out how long would it take for the football to reach the maximum height from the ground where it was initially kicked, right? So here's the equation. Vfy is equal to Viy plus Ay into t. Here, Vfy is the velocity of the football when it reaches maximum height. Viy is the velocity when the football is originally kicked, and Ay is the acceleration of the football when it is at maximum height. And time is what we're trying to calculate, and that is the time it would take for the football to reach the maximum height from the ground. Okay, so here's a diagram to help you understand what I mean by vertical component of the velocity vector. So whenever you have a vector, velocity vector at an angle, it'll have a horizontal component and it'll have a vertical component. In this case, we are only interested in the vertical component, since the vertical component of velocity is the only thing that is responsible for this equation out here, and is governing this equation. Um, in order to find out how long would it take for the ball to reach maximum height. Okay, so let's first find out what's the vertical component of the initial velocity. So VIY would be equal to VI, which is the initial velocity with which the ball was kicked, times sine of theta. And that is 18 times sine of 31 degrees, which would be 9.27 meters per second. So we found out the vertical component of the initial velocity. Now we have to find what is the uh, velocity at the maximum height. And the velocity at maximum height is 0 meters per second. This is because as the ball approaches the maximum height, it loses velocity due to gravity, right? Since gravity is acting on the ball continually, it keeps losing velocity. But you can see that acceleration of the ball at the maximum height is negative g. It's negative because gravity is acting in a downward direction. And I said before that the downward direction is the negative direction, right? So that's why acceleration of the ball at maximum height will be negative 9.8 meters per second square. So we rewrite the equation by isolating t, which gives us t equals to vfy minus viy over ay, right? And then we just write down the numbers, just plug in the numbers, and we have 0 minus 9.27 over negative 9.8. This gives us an answer of 0.946 seconds. So it takes the ball 0.946 seconds to reach maximum height. But we haven't quite found the solution yet because we want to find how long is the ball in air. So in order to find that, we know that it takes, some time t to reach the maximum height, and it would take that same amount of time for this ball to go to the ground from this maximum height. So the time taken by the ball to hit the ground would be 2 times small t, which is 2 times 0.946, which comes out to be 1.89 seconds. So it would take the ball 1.89 seconds to hit the ground again after it has been initially kicked.